Okay, everyone, welcome back. We are now into part 4 of titrations. This is the last and final region of the titration curves. In the next 2 videos, we will try to summarize what has happened over these past 4 videos to try to give you a bigger picture idea of what is happening. But in this video, we are going to talk about what is happening beyond the equivalence point. And so just to give you a reminder, we are still working with the sodium acetate plus HCl going to form acetic acid plus Cl minus, not Cl minus, NaCl. We are still working with this same titration reaction. Okay, so at this point, we want to determine the pH of 10 milliliters of sodium acetate when 18 milliliters of 0.3 molar HCl has been added. Now, remember from one of our previous videos that the equivalence point is when 16.67 milliliters of HCl has been added. So now with 18 milliliters, we are beyond the equivalence point. So we, again, our first step is determine what is in solution. So you should start seeing the pattern. This is the first step in every titration problem. And so we have sodium acetate plus HCl goes to form NaCl plus acetic acid. And we need to find out what is in solution. And so we have a single arrow, which means that we are doing stoichiometry. And that means that we need to use moles. And remember that moles is equal to the concentration times the volume. And so we have 5 times 10 to the minus 3 moles of sodium acetate. And we have 5.4 times 10 to the minus 3 moles of HCl. And we have 0 moles of acetic acid at the beginning of this reaction. In this case, our sodium acetate is our limiting reagent, leaving us with 4 times 10 to the minus 4 moles of HCl and 5 times 10 to the minus 3 moles of acetic acid. So now that we know what is in solution, we have a weak acid and we have a strong acid. When you have a weak acid and a strong acid in solution, the strong acid controls the pH. The weak acid will contribute a small amount to the pH, but it is not enough for us to worry about. And so in our next step, in step 2, we need to find the pH. And in this case, we are going to be finding the pH of a strong acid. And so when we have a strong acid in water, it does not form an equilibrium. Instead, it completely dissociates. And so that means that we get to do stoichiometry in order to find the pH. And so we are starting with 4 times 10 to the minus 4 moles of HCl and no moles of H3O plus, and we can assume an infinite amount of water. And so that means that all of my HCl, this is my initial, this is my final, all of my HCl reacts to form H3O plus. And so this is 4 times 10 to the minus 4 moles of H3O plus. And the pH is equal to minus log of the H3O plus concentration. And the concentration of H3O plus is going to be 4 times 10 to the minus 4 moles divided by the total volume. And the volume is going to be my 10 milliliters plus my 18 milliliters, which is 28 milliliters, or 0.028 liters. And so my concentration of H3O plus is equal to 0.0143 molar. And so my pH is equal to 1.84. And this makes sense because I have a strong acid in solution, and so the pH should be low. And so past the equivalence point, you are going to have a strong in solution always, and you find the pH of strong acids or bases using stoichiometry. Okay, so in the next video and the one after that, we're going to talk through titration curves as a big picture and what is happening in each region. And then we will go into how to analyze experimental data with a weak-based strong acid titration. So stay tuned for those. And remember, I have lots of office hours and I'm discussion sessions, and our TAs are around, discussion board posts. Please use your resources and ask lots of questions. Thank you.